Hi, this is a lecture about networking prerequisites. So in this video, I'm going to teach you the basics of networking. This will be really helpful for you if you are working in Linux environment, or if you are trying to work in Kubernetes cluster, or if you are working with Docker. So wherever networking is involved, learning these fundamentals will be really helpful for you. And I assure you this tutorial will be easy to understand, and after completing the video you will have better understanding on how the communication from one machine to another machine happens, and you will get familiar with all the networking terminologies. So in this particular video we are going to talk about switching and routing and how a default gateway is useful. And to understand all these, we are going to take some example and see how communication from one machine to another machine is happening from one network to another. So without waiting much, let's get started. So we have two machines or two computers, A and B. How do they talk to each other? The answer is we connect them to a switch. We need network interfaces on both the machines. This network interface could be physical or virtual depending on the host machines. To see the network interface, you can run the command ip-link. So this is the command. When I run it, you can see it has listed all the network interfaces. The first one is loopback, second one is enpls, third one is docker 0, and so on. So these are the network interfaces available on this host. This is just an example on Killer Coda Playground, but you can run the command on your own machine and see this. Just in case if you are not using Linux, on Mac you can use ifconfig command, and this will list all the network interfaces. So different command can be used depending on the OS to see the network interfaces. Then the system are assigned the IP addresses with the same network IP range using the following command: ipaddr add 192.168.15/24 dev 880. And on machine B, you can run the command ipaddr add 192.168.1.20/24 dev 880. So by running this command, machine A has the IP address 192.168.1.15 and machine B has the IP 192.168.1.20. Once the link is up and the IP addresses are assigned, machine A and B can now talk to each other through the switch. If you do a ping 192.168.1.20 from machine A, then it should be able to talk to machine B. The switch only enables the communication within a network, which means it can receive a packet from a machine or system within the network and deliver it to other machine within the same network. Now let's suppose we have another network having machine C and D, and the machine C has the IP address 192.168.2.15 and machine D has 192.168.2.20. Here also there is a switch to connect machine C and D, similar to what we have between machine A and B. But here in this case, you can see the network is 192.168.2, and in the first network it is 192.168.1. Now the question is, how does the machine in network 1 connect or talk to the machine in network 2? That means, how does machine B with IP 192.168.1.20 can talk to machine C with IP 192.168.2.15? So this is where the router comes into the picture. A router helps to connect two networks. You can think of a router as a server which has many network ports. Since here it connects two networks, it gets two IP assigned, one on each network. So router will have 192.168.1.1 IP for one network and 192.168.2.1 for the other network. Now when the machine B wants to send the packet to machine C, how does it know how to send the packet through router? Because router is just another device in the network, and there could be many such devices within the network. So the answer is gateway. This is where we configure a gateway or a route. Consider a network is a room and gateway is like a door to the outside world or to any network or internet. So machine B should know where the door is. To check existing routing configuration, you can use the following command. The command is route. So let's quickly run this command on Killer Coder Playground. And as you can see, this particular host has following entries. So it has column destination, gateway. So destination is where you want to reach from this machine. So these are the destination IPs, and gateway is the door through which this host will be able to reach to these destinations. We will see how these entries are populated shortly. So considering the example, as of now we don't have any entries in any of the machine. So if we run the command route, the route table will be blank. If the output shows no data, then no route is configured and machine B will not be able to send data through router. To add a gateway to the machine, you can run the following command: IP route add 192.168.2.0/24 via 192.168.1.1. So with this command, we are adding a route to reach to IP 192.168.2.0 via the router IP, that is 192.168.1.1. So once you run this command on machine B, the machine B will know to reach to this IP range 192.168.2.0, it needs to go through the router which has the IP 192.168.1.1. Since we are adding this to B, please note that all machines within the network should be configured with this route so that they are aware about the router to reach to this particular destination. Now machine B knows to reach to machine C through router, but machine C doesn't know as of now how to reach to machine B. The answer is same. We need to add a route on machine C, and the command will be IP route add 192.168.1.0/24 via 192.168.2.1. So this way we are saying to machine C to reach to machine B network, you can go through the router 192.168.2.1. So this is how two machines can communicate with each other on different network through a router. Now the next part is connecting to internet. To connect to internet over network 172.217.184.0 from machine C, we add a route on machine C. So we use the command IP route add 172.217.194.0/24 via 192.168.2.1. Now there are many websites over different network on internet. So will you add route for all the networks? The answer is no. This is where a default gateway comes into the picture. So we don't add entries for all the networks. We simply add one route with the default gateway with the command IP route add default via 192.168.2.1. So when we run this command on machine C, this command essentially means for which we don't know the route to, use 192.168.2.1 as the gateway, and instead of using the word default, you can use 0.0.0.0, which means any IP destination. So in the following route table, we have two entries. One is default and the gateway is 192.168.2.1. So this means to go to any destination or any network, use the gateway 192.168.2.1. And we have another entry in which the destination is 0.0.0.0. The gateway is same. So both entries means the same thing. If we are on machine C, and if you see the third entry 192.168.2.0 is the destination and the gateway is 0.0.0.0. So this means to go to any destination within the same network, it doesn't require a gateway and it can reach directly through switch. Suppose you have two routers, one for internet, another one for a private network, then you will need separate route entries. So the route table will look like this. The destination is default, then the gateway is 192.168.2.1, and if destination is on this particular network like 192.168.1.0, then the gateway which should be used is 192.168.2.2. So just in case if you have issues connecting to internet from your system, checking route table is a good starting point. Now we have a fair understanding of switches and routers. Let's try to set up a Linux host as a router. So consider we have following setup. There are three machines A, B, C. A has interface 8080 and is on network 192.168.1.0. B has two interfaces 8080 and 80H1 and is connected to both the network, that is 192.168.1.0 and 192.168.2.0. and then there is machine C which has interface 8080 and this is connected to the network 192.168.2.0, and these are the corresponding IPs of all these machines. Machine B will have two IPs because it has two interfaces. So this is what is going to act as a router. Now the question is how A should be able to talk to C. If we ping 192.168.2.3 from machine A, it will say network unreachable. And we know the reason, which is obvious, because the routes are not configured and A has no idea how to reach to machine C. So we need to tell machine A that the door to machine C is through machine B by adding a routing table entry. So on machine A we can run the following command: IP route add 192.168.2.0/24 via 192.168.1.4. Now A knows how to reach machine C, but C doesn't know how to reach A. So we need to add the entry in the routing table of machine C. So the command is IP route add 192.168.1.0/24 via 192.168.2.4. Now the ping should work, but still we will not get a response packet. This is because in Linux by default packets doesn't get forwarded from one network interface to another network interface. In this case machine B, the packets doesn't get forwarded from 8080 to 80H1 interface. This is because of security reason, because 8080 can be connected to a private network and 80H1 could be connected to internet, and we might not want anyone on the internet or external network to send data to internal private network through 8080. But here in this case we want to enable communication between these two interfaces so that we can connect these two networks of machine A and C. So B can forward the packet from one interface to another interface. So this is governed by a setting in Linux which can be seen in the file /proc/sys/net/ipv4/ip_forward. If you cat this file and the output is 0, then the forwarding of packets from one interface to another is disabled, and if it is set to 1, then forwarding of packets between interfaces is enabled. You can enable it by this command echo1 to this particular file. But remember, simply setting this value to 1 in this file doesn't persist the changes through system reboots. To persist these changes, we should set this value in the file /etc/sysctl.conf, and the parameter which should be set is net.ipv4.ip_forward, and the value should be set to 1. So once this is set, machine A will be able to talk to machine C and B will act as a router. So this is how the communication between machines in different network or internet happens.